Hi students, now we are going to discuss about colloids and dispersed base and dispersed medium. Colloids. What is meaning of colloids? The scientist Graham, Thomas Graham pointed out that some of the substance has rate of diffusion more faster. Some of the substance has rate of diffusion very slow. For example, acid. Then base, salt, sugar, urea. These substances has a rate of diffusion on the parchment membrane, rate of diffusion on the cellophane sheet then more faster. Another one, glue, gelatin, and then albumin, gum. These substances has a rate of diffusion very slow. The rate of diffusion of more faster substance otherwise called crystalloid substance. Crystalloid substance. The rate of diffusion very slow substance. So slow substance otherwise called colloid substance. Colloids. These substances called colloidal substance. What substance? Glue, gelatin, albumin, gum has rate of diffusion on the parchment membrane. Rate of diffusion on the cellophane sheet has done very slow. So these substances known as a colloidal substance. Colloid substance. The colloidal substance can be prepared from any other substance is reduced to 1 nanometer to 200 nanometers. In general, the colloidal solutions are homogeneous mixture of two substances. Gas in gas, gas in liquid, gas in solid, and then solid in gas, solid. So two substances then homogeneously mixed with each other, or then two substances homogeneously throughout the mixture of then compounds known as a colloidal substance. The colloidal substance has two substances. One is a smaller proportion, another is a larger proportion. Smaller proportion otherwise called a dispersed base. Larger proportion otherwise called a dispersed medium. So then colloidal is a homogeneous mixture of two substances. One substance has a smaller proportion, another substance has a larger proportion. Smaller proportion is a dispersed base, larger proportion is a dispersed medium. The dispersed base is dispersed in dispersed medium. So in then what? Smaller proportion of dispersed base dispersed in the larger proportion of dispersed medium to form of solution known as a colloidal solution. Okay. In another one, classification of colloidal solution. In the colloidal general, the colloidal solution which contain dispersed base is a liquid, dispersed medium is a dispersed base is a solid, dispersed medium is a liquid. In general, all colloidal substances. In all colloidal substance has dispersed base is a solid, is a dissolved in or dispersed in, dispersed medium as a liquids. If the dispersed medium is a water, then colloidal substance otherwise called hydrosol. Dispersed medium is water. H2O means then colloidal solution otherwise called hydrosol or aquasol. Hydrosol or aquasol. If the dispersed medium is alcohol, then colloidal solution otherwise called alcohol. If the dispersed medium is benzene. What is the form of benzene? C6H6. If the dispersed medium is benzene, then colloidal solution otherwise called benzosol. So is a depend upon dispersed medium. In the colloidal solution classified in different types. It is a depend upon dispersed medium. Colloidal solution classified in different types. If the dispersed medium is a water, then colloidal solution otherwise called hydrosol or aquasol. If the dispersion medium is alcohol, then colloidal solution otherwise called algazole. If the dispersion medium is a benzene, then colloidal solution otherwise called benzosol. Another one important classifications are there. In the depend upon attractive forces between the dispersive base and dispersion medium. Depend upon attractive force. Attractive force in between dispersive base and dispersion medium. Dispersive base and dispersion medium. It's a depend upon attractive forces in between the dispersive base and dispersive medium. It is classified into two types. One is a lyophilic substance. Another one lyophobic substance. Lyophilic and lyophobic. Lyo means sal. Philic means attracting. Sal attracting substance otherwise called lyophilic substance. Lyophilic colloids. Example, protein, then starch. So example of a lyophilic substance. Lyo means sal, philic means attracting, sal attracting or dispersion medium attracting substance known as a lyophilic substance. Example, protein and starch. Another one, lyophobic. Lyo means sal or dispersion medium. Phobic means hating. So dispersion medium hating substance or attractive forces hating substance otherwise called lyophobic substance. In the lyophobic substance example, in the colloidal solution of copper, in the platinum, rhodium, then argentum, silver. It is an example of a lyophobic substance. So what is the meaning of lyophilic substance? In the colloidal solution in which dispersed base gas considerable affinity for the dispersion medium. Dispersed base gas very strong attractive forces with the dispersion medium known as a lyophilic substance. The lyophilic substances are more stable, cannot be easily precipitated. By using of a suitable dispersion medium, those substances again return back to original salt. By using of suitable dispersion medium, the substance again return back to original compounds, dispersive base, dispersion medium. So, the lyophilic substances are reversible substance, reversible salt, reversible. Already we have learned in 11th standard. Reversible, chemical equilibrium, reversible process. What is the meaning of reversible? The reactant can be converted to product further recombined to form of original reactant known as a reversible reaction. Lyophilic substance also a reversible reaction. Then colloidal solution in which dispersed base gas considerable affinity for the dispersed medium or very strong attractive forces in between the dispersed base and the dispersed medium known as a lyophilic substance. For example, proteins or starch. In this lyophilic substance or lyophilic compounds or lyophilic colloids all are more stable, can be converted into precipitate by using of suitable dispersed medium. Those substances return back to form of original reactant. So in the lyophilic substance are reversible colloids or reversible substance. Next one, lyophobic. In the colloidal solution in which dispersed base gas there is no attractive forces with the dispersed medium or in the dispersed base gas in the very little attractive forces with the dispersed medium or there is no attractive forces in between the dispersed base and dispersed medium known as a lyophobic substance. So what is a simple concept of lyophobic substance? There is no attractive forces in between the dispersed base and the dispersed medium known as a lyophobic substance. For example, colloidal solution of metals. Colloidal solution of coinage metals, 11th group elements, copper, silver, rhodium, platinums. This substance is less stable. It easily can be converted into precipitate. By adding suitable dispersed medium, those substances cannot be returned back to form of original reactant known as a lyophobic substance. So, in the lyophobic and the lyophilic substance can be classified is depend upon nature of the attractive forces in between dispersed base and also dispersed medium. Next one, depend upon physical force or physical state. Depend upon physical state or physical force. In the colloidal substance classified into 8 types. The solution classified into 9 types. But colloidal substance can be classified into 8 types. In the first one, gas in gas is a completely miscible to form of true solution. Example, air. The first one, gas in gas. Another one, gas in liquid, then gas in solid, in then liquid in gas, liquid in gas, liquid in liquid, then liquid in solid, solid in gas, solid in liquid, solid in solid, solid in solid, solid salt. Name is solid salt, alloys, all alloys. Solid in liquid, amalgam, solid liquid, in form of gel, amalgam substance. Especially the amalgam which contain mercury. Mercury can combine with alkyl metal, alkyl earth metal, or any other substance. Then gel. Solid in gas, solid in gas. Then solid foam, solid foam. For example, pumice stone. In the liquid in gas, salt. Liquid in liquid, emulsion. Emulsion. Liquid in gas, then foam. Foam, liquid in gas. Gas in solid. Gas in solid. Solid aerosol. Solid aerosol. Gas in liquid. Liquid aerosol. Liquid aerosol. Gas in gas. Yeah, it is a except gas. For example, nitrogen oxygen mixer. By using deep sea divers, nitrogen oxygen mixer, nitrogen helium mixer. So, except gas in gas, remaining all then combinations are colloidal substance. Then gas in gas completely miscible to form of true solution. In then gas in liquid, gas in solid, liquid in gas, liquid in liquid, in the liquid in solid, then solid in gas, solid in liquid, solid in gas. These substances are colloidal substance. So, is a depend upon physical state or is a depend upon physical force of attraction. These colloidal substances classified into 8 types. Gas in liquid example, liquid aerosol. In then gas in solid example, solid aerosol. Liquid in gas example, foam. Liquid dispersed in liquid emulsion. Liquid dispersed in solid salt. Solid in dispersed in gas is a solid foam. Solid dispersed in liquid is a gel. And then solid dispersed in a solid substance is solid salt. Solid salt is an example of a classification of a colloidal substance is depend upon physical state. It is one of the classification of colloids. Next one, preparation of colloids. Preparation. Preparation of colloids. Colloids. In the colloid, 3 types of important solutions are there. One is a true solution, colloidal solution, suspended solution. True solution. True solution. Colloidal solution. Another one, suspension solution. Suspension solution. What is the example of true solution? True solution. For example, sugar in water. Sugar in water. Sugar completely dissolved in water molecule to form a true solution. Because of, in the sugar substance is a small quantity, that means called solute. In the water is a larger quantity, that means called solvent. So, the sugar substance is completely miscible with water molecule to form of a true solution. Another one, colloidal solution. In the, for example of a gel in water, it is a colloidal solution example. Suspended solution, sand in water. True solution containing dispersed particle, diameter of the dispersed particle very small. In the diameter of the dispersed particle ranges from 1 to 10 Armstrong. 1 to 10 Armstrong. So, the true solution contains a dispersed particle, diameter of the dispersed particles 1 to 10 Armstrong. Suspension solution contains in then what? Dispersed particles, diameter of the dispersed particles 2000, more than 2000 Armstrong. In the colloidal solution contains dispersed particle ranges in between. Colloidal solution contains dispersed particle size ranges in between 10 Armstrong to 2000 Armstrong. 10 Armstrong to 2000 Armstrong. So, true solution contains dispersed particles diameter 1 to 10 Armstrong. Suspended solution contains dispersed particles diameter 2000, more than 2000 Armstrong. Colloidal solution contains dispersed particles, size of the dispersed particles in between true solution and suspended solution. True solution and suspended solution. Compare the three substances contain dispersed particles, size of the dispersed particles. True solution contain dispersed particle very very small. So in the true solution or salt can be converted into colloidal solution one way. True solution can be converted into colloidal solution or colloidal dimension one way. Another one, suspension. Suspension solution containing dispersed particle can be converted into colloidal solution. One way, true solution can be converted to colloidal solution. Another one way, suspension containing dispersed particle can be converted into colloidal dimension. Two methods are there. Preparation of colloidal substance. True solution can be converted into colloidal solution by using condensation method because of true solution containing dispersed particle very very small. The smallest particle coming in contact with each other to form of large size of colloidal particles. In this method, true solution can be converted into colloidal solution by using of condensation method. Because of small size of the dispersed particle condense or coming in contact with each other to form of colloidal solution. Another one, suspension solution containing dispersed particle can be converted into colloidal solution, colloidal salt or colloidal dimension by using dispersion method. Because of suspension solution containing dispersed particles goes of aggregating large size, bigger size than the colloidal solution. That's why by using of dispersion method, the suspension solution containing colloidal particles can be converted into, or suspension solution containing diameter of the particle can be converted into colloidal solution by using of dispersion method. So colloidal solution can be prepared from true solution by using of condensation method. Colloidal solution can be prepared from the suspension solution by using of dispersion methods. So two methods are there. One is a condensation method, another one is a dispersion method. In general, most of the lyophilic substance, most of the lyophilic colloids can be prepared by those substances dissolved in warm water. For example, rubber. In the rubber particles initially exist as a colloidal particles. In the rubber particles always exist in colloidal solution in benzene. Another one, soap solution. Soap solution is always spontaneously exist as a colloidal substance. Spontaneously exist as a colloidal substance in water. Substance. So soap is spontaneously exist as a colloidal solution in water. Rubber particle initially exists in a benzene. It is an example of a lyophilic substance, another is a lyophilic substance. Because of soap solution in water known as a lyophilic substance, rubber in water known as a lyophilic substance. In the rubber in water is example of benzo salt. In the soap in water is example of aqua salt. Because of already I have told to you, in the dispersion medium is a benzene, means the colloidal solution otherwise called benzosol. So rubber particles dispersed in benzene known as a benzosol. Another one, if the dispersion medium acts as a water molecule, means to form of aquasol or hydrosol. So soap solution dispersed in water otherwise called aquasol or hydrosols. So in this substance is example of lyophilic substance. This substance is example of lyophilic substance because of rubber is a dispersed base, in benzene is a dispersed medium, here soap is a dispersed base, water is a dispersed medium. In this colloidal solution contain a dispersed base and a dispersed medium have very strong force of attraction. That's why in this substance is a reversible colloids, otherwise called lyophilic colloids. So rubber in benzene, attractive forces in between the rubber and benzene very very low, or very little force of attraction between the rubber in benzene. That's why these substances are otherwise called a lyophilic substance. The lyophilic substances are less stable, easily precipitate. By using a suitable dispersion medium, cannot be easily returned back to form of original reactant. That's why rubber in benzene is an example of irreversible salt. Soap in water is an example of reversible salt. Okay. So two methods are there. In general, preparation of colloidal substance. Two methods are there. One is a condensation method, another one is a dispersion method. By using of dispersion method, suspension solution containing a large size of the colloidal particle can be converted into small size of the colloidal solution containing dispersed particles. Another one, in the condensation method, in the true solution containing smallest particles can combine to each other's to form of colloidal solution. Okay. In the now we are going to discuss about in the first one, what? Condensation method. Condensation. By using of condensation. In the substance which contain small size of the true solution containing dispersed particles can be converted into in the large size of the colloidal solution containing dispersed particles by using of condensation method. In the following process, it takes place in a condensation process. First one, in the oxidation. Another one, reduction. Oxidation, reduction. Third one, in the hydrolysis. In the fourth one, double decomposition. Double decomposition. In the fifth one, in the what? Decomposition only. Double decomposition. Oxidation method. In the oxidation method is used to suitable for the preparation of some of the non-metal salt. For example, hydroiodic acid, HiO3, hydroiodic acid is treated with hydrogen iodide to form of iodine salt, I2, iodine salt plus water. Iodine is a non-metal. Another one, in the oxygen gas, O2, oxygen gas, is a passes through hydrogen selenide, H2SE, hydrogen selenide. In the what? The hydrogen can be combined with the 16th group elements. Oxygen, sulfur, selenium, tellurium, polonium. Hydrogen can combine with the oxygen to form of hydrogen oxide. 16th group elements. Oxygen, sulfur, selenium, tellurium, polonium. Polonium is a radioactive elements. In the first four elements exist as a in the solid as well as a gas. Oxygen gas, sulfur, selenium, tellurium are solid. Okay. In the oxygen can be combined with hydrogen to form of water. H2O, otherwise called hydrogen oxide. Sulfur can be combined with hydrogen to form of hydrogen sulfide, H2S. In then selenium can be combined with hydrogen to form of H2SE, hydrogen selenide. In then what? Tellurium can be combined with hydrogen to form of hydrogen telluride, H2TE. So hydrogen oxide, hydrogen sulfide, hydrogen selenide, hydrogen telluride. By using of hydrogen selenide, H2SE, hydrogen selenide, the oxygen gas passes through hydrogen selenide to form of selenium salt plus H2O remove. So iodine non-metal, selenium also non-metal. So the non-metal salt can be prepared from oxidation method. It is important. Another one, reduction. Some of the chemical compounds are there, important reducing agents. Phenylhydrazine, CH5NH, in the NH2, phenylhydrazine. In the 2,4 DNP, 2,4 in the DNP, 2,4 DNP, 2,4 dinitro, phenylhydrazine. Phenylhydrazine example, phenylhydrazine formula C6H5NH2. In the 2,4 DNP, 2,4 dinitro phenylhydrazine formula C6H3 in the NO2 twice NH2. In the phenyl group, what is the formula of phenyl group? C6H5. How many hydrogens are there in phenyl? 5 hydrogen. 2 hydrogen replaced by 2 NO2 group. So 2,4 DNP. It is a phenylhydrazine. Is a 2,4 then dinitrophenylhydrazine, formaldehyde acetaldehyde, glucose, those substances are reducing agent. Those substances which easily reduce the auric chloride to aura metal, silver nitrate to silver salt. So auric chloride, AuCl3 is treated with formaldehyde HCHO plus water H2O gives auric chloride can be converted to aurum salt, Au salt, aurum salt plus in the formaldehyde can be oxidized to form of formic acid HCOH plus in the what? In the hydrogen can be combined with chlorine to form of hydrochloric acid HCl. Here auric chloride contain aurum exhibit the what oxidation state 3 plus oxidation state. Aurum salt contain aurum metal exhibit the what oxidation state 0 oxidation state. Formaldehyde contain carbon exhibit the what oxidation state. How to find out the oxidation state of carbon? How many hydrogens are there? 2 hydrogen. So each hydrogen exhibit the plus 1 oxidation state. So 2 hydrogen, 2 oxidation state. So plus 2 plus carbon exists as a X or carbon can be represented as a X. All oxygen except peroxide, superoxide, monoxide, then ozonoide. In this compound contain oxygen exhibit the minus 2 oxygen state plus minus 2 equal to 0 because of there is no charge on the compound. So 2 hydrogen and 2 carbon can be expressed as X, oxygen, then oxygen state of oxygen minus 2 equal to 0. X equal to 0. So 2 plus 2 and minus 2 cancel, X equal to 0. So oxygen state of carbon in formaldehyde 0. Don't forget, oxygen state of carbon in formaldehyde 0. Next one, formic acid, HCOH. How many hydrogens are there? 2 hydrogen. So each hydrogen exhibit the plus 1 oxygen state. So 2 hydrogen exhibit the plus 2 oxygen state. Okay. Next, plus, how many carbons are there? Only 1 carbon. That carbon can be expressed as a X. Then, how many oxygens are there? 2 oxygen. Each oxygen exhibits the what oxygen state? Minus 2. So 2 into minus 2 equal to minus 4, which is equal to 0 because of there is no charge on the compound. Okay. In then 4 minus 2 equal to minus 2 equal to 0. X which is equal to 2. So formic acid contain a carbon exhibit the plus 2 oxygen state. Formaldehyde contain a carbon exhibit the 0 oxygen state. Here auric chloride can be reduced to aura metal because of plus 3 oxygen state can be changes to 0. So plus 3 oxygen state can be changes to 0. So oxidation number decreases. The process reduction process here formaldehyde acts as a reducing agent. Don't forget phenyl hydrazine 2,4 DNP 2,4 dinitrophenyl hydrazine acetaldehyde formaldehyde any other aldehyde. In then even glucose also acts as a reducing agent. So here formaldehyde acts as a reducing agent which reduce the auric chloride can be converted to aura metal. Next one. In then formaldehyde contain a carbon exhibit the 0 oxygen state. Formic acid contain a carbon exhibit the plus 2 oxygen state. Here oxidation number increases from 0 to plus 2. Oxidation number increases from 0 to plus 2. So oxidation number increases means what process? Oxidation process. Auric chloride acts as an oxidizing agent. The process, the reaction is called a redox reaction. What is meaning of redox reaction? Both reduction as well as oxidation takes place simultaneously in a single reaction or a redox reaction. In the reaction is an example of redox reaction. Another one is an example of a reduction reaction. Auric chloride can be converted to aurum salt. And in same reaction, silver nitrate, AgNO3, silver nitrate, react with formaldehyde, HCHO or tannic acid or phenyl hydrazine or 2,4 DNP or acetaldehyde within water to form of. In the silver nitrate can be reduced to silver mirror plus formaldehyde oxidized to form of formic acid HCOH. In the hydrogen in water molecule, then nitrate in silver nitrate to form of nitric acid HNO3, nitric acid move. Here plus 1 oxide of silver can be reduced to 0. Reduction process. So formaldehyde is a reducing agent. 0 oxygen state of formaldehyde can be oxidized to plus 2. So in the process oxidation process, silver nitrate acts as a oxidizing agent. In this process also redox reaction. Okay, it's an example of reduction process. Another one, hydrolysis. Hydroxide is all of. Hydroxide is all. Iron hydroxide, chromic hydroxide, in the Aluminum hydroxide. Hydroxide salt can be prepared from hydrolysis of respective salt. So respective salt of ferric chloride FeCl3, chromic chloride CrCl3, aluminum chloride AlCl3. Hydrolyzed by water H2O, and then H2O. And then chlorine replaced by OH group. The OH group obtained from the water molecule. So ferric hydroxide FeOH thrice, chromic hydroxide CrOH thrice, in the aluminum hydroxide AlOH thrice plus HCl, hydrochloric acid, HCl. So hydroxide salt, ferric hydroxide, chromic hydroxide, aluminum hydroxide. Hydroxide salt can be prepared from hydrolysis of ferric chloride, respective salt. Hydrolysis of respective salt. Ferric chloride can be converted to ferric arsenic oxide to form of arsenic sulfide plus H2O, water remove. So arsenic sulfide salt can be prepared from hydrogen sulfide passes through arsenic oxide. So slow steam of hydrogen sulfide is a passes through dilute solution of arsenic oxide to form of arsenic sulfide. It is a double decomposition method. What is the meaning of double decomposition? Double means two. Decomposition means those substances are dissociated, disintegrated or decomposed. Hydrogen sulfide as well as arsenic oxide. Both the substances are dissociated or decomposed to form of arsenic oxide. That's why in this process, for example of double decomposition process. Next one, decomposition reaction. In the small amount of acid, H plus ions. The H plus is nothing but nitric acid, inorganic acids, mineral acids, nitric acid, sulfuric acid, hydrochloric acid, phosphorus acids, any other acids. In the H plus ions is added to sodium thiosulfate S2O3 2 minus. What is the formula of sodium thiosulfate? Na2S2O3. 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 In the Na2S2O3 dissociate of 2Na plus S2O3 2 minus. 2 plus positive charge. That's why 2 minus charge. So S2O3 2 minus. So acid or mineral acids are added to in the sodium thiosulfate solution to form of free sulfur. In the free sulfur can be obtained from decomposition of thiosulfate solution. Decomposition or dissociation of thiosulfate solution plus water H2O and sulfur dioxide SO2 remove. H2O and SO2 sulfur dioxide remove. It is one method. Another one method is that. Next one, dispersion method. Totally 4 types of dispersion methods are there. First one, mechanical dispersion. Mechanical dispersion or by using colloidal mill. Colloidal mill. Mechanical dispersion, colloidal mill. Then second one, electro dispersion. Electro dispersion or predict arc method. Predict arc method. Next one, ultrasonic dispersion. Ultrasonic dispersion. Then peptidization. Peptidization. Another methods are there by exchange of solvent. Exchange of solvent. By exchange of solvent. Simple methods are by exchange of solvent. Solvent exchange in between the dispersion base and dispersion medium. Known as exchange of solvent. By, for example, in the preparation of colloidal solution of phosphorus or sulfur. The colloidal solution of phosphorus or sulfur can be prepared by in the vapor of phosphorus and sulfur in alcohol poured in water. So phosphorus in alcohol poured in water to form of phosphorus salt. Sulfur in alcohol sulfur gas. Vapor of sulfur in alcohol poured in water to form of sulfur salt. Sulfur salt. The sulfur salt, phosphorus salt are liquid. The sulfur, phosphorus, vapor. So for what is the meaning of exchange of solvent? Gas can be converted to liquid. Exchange. Solid can be converted to liquid. It is an exchange of solvent. So in the vapor of phosphorus and sulfur salt or vapor of phosphorus sulfur is in alcohol poured in water to form of respect to salt, phosphorus salt or sulfur salt. It is an example of by exchange of solvent. First one, mechanical dispersion method. What is by using of dispersion method in true suspended solution can be converted into colloidal solution because of suspended solution contain a dispersed particle diameter higher than the colloidal solution. That's why suspended solution contain a particle can be converted to colloidal solution by using of dispersion method. First one, colloidal mill, mechanical dispersion. In the mechanical dispersion is nothing but a simple experiments are there. Colloidal mill. The colloidal mill consists of two steel plates touching with each other. The two steel plates in the rotating in opposite direction with high speed. The speed of the two steel plate rotating 7,000 revolutions per minute. So in per minute, the two steel plate rotate in 7,000 times. So it is a simple experiment. It is a example of colloidal mill. In the solid substance of the suspension particle fed into the colloidal mill. In the colloidal mill consists of two steel plates touching with each other. In the two steel plates rotating in opposite direction with high speed. So solid substance dispersed in between the two steel plates to form of a colloidal solution. This method is used for the preparation of colloidal ink and then graphite. Colloidal ink and colloidal graphite. Colloidal graphite and colloidal ink can be prepared by in the colloidal mill. Required size of the dispersed particles, that means called required size of the in the colloidal particle can be prepared by adjusting distance in between the two steel plate. In the distance in between the two steel plate very small means small size of the colloidal particle can be obtained. The distance between the two steel plate larger means larger size of the colloidal particle can be obtained. So required size of the in the particle of colloidal solution can be prepared by adjusting in the distance in between the two steel plate. It is a colloidal mill. So colloidal mill is otherwise called a mechanical dispersion. The mechanical dispersion is used for the preparation of colloidal ink and colloidal graphite. One method. Another one, electrode dispersion, Predict arc method. In the brown colored solution of platinum, first prepared by Predict in 1898 by using of electrode dispersion container. What is the meaning of electrode dispersion container? In the water molecules placed in one beaker. Water placed in beaker. Inside of the water, metal arcs are there. Metal arc. What metal arc? Required colloidal solution of the metal can be prepared by using of metal is placed in inside of the water molecule. For example, platinum arc, copper arc, arum arc, silver, Ag, silver arc. In the arc placed in inside of the water molecule in a beaker. Okay. In the circumference of the circular arc can be struck by using of two metal electrode. One is a positive electrode, another one is a negative electrode. One positive electrode, negative electrodes. After striking of in the metal arc inside of the water molecule, in the temperature of the water increases. So temperature of the water molecule can be stabilized by using of some stabilizing agent. What stabilizing agent? Alkali metal hydroxide. It means called potassium hydroxide. Again, temperature of the water molecule increases. In the water molecule can be decreased by those containers placed in ice cold bath. Those containers placed in ice cold path. It is ice cold path. In the ice cold path, it is used to decrease the temperature of the water molecule. Temperature of water molecule is ice cold path. Temperature of water molecules. Okay. When struck the electrode when struck the circumference of the arc by using a metal electrode, in the intense heat of the water molecule increases. In the intense heat of the vapor or water molecule condensed on the metal, the metal means a circumference of the circular arc, and then condensed to form of respective colloidal solution. Platinum solution, copper solution, solution, silver solution. Okay. Then another scientist, Swedberg. The Swedberg, it is modified in the mechanical, is electrodispersion. Modify the electrodispersion by using a preparation of non-aqueous inflammable colloids. Non-aqueous inflammable colloids is nothing but pentane, ether, benzene, other organic substance can be prepared by using of in an electrodispersion by using of Swedberg in high frequency of alternating current. In the high frequency of alternating current which prevent the decomposition of substance. Decomposition of substance. It is a method. It is a what? Mechanical dispersion or periodic arc method. The mechanical dispersion periodic arc method, it is used to preparation of in the colloidal solution of 11th group elements or coinage metals of copper, silver, platinums. Okay. Next one, ultrasonic dispersion. Ultrasonic dispersion. In the ultrasonic dispersion is nothing but sound wave with high frequency more than 20 kilohertz. Greater than 20 kilohertz. In the more than 20 kilohertz of sound wave with high frequency is a passes through solid substance break down to form of colloidal solution. It is a simple example, simple methods. So what is the meaning of ultrasonic waves? Sound wave with high frequency. So more than 20 kilohertz. In the frequency of high frequency of in the what? Alternating current or high frequency of ultrasonic vibration. In the high frequency of ultrasonic vibration is a passes through in the solid substance break down to form of colloidal solution. Okay. In the class, scientists suggest that from this method, from this ultrasonic dispersion method, mercury salt can be prepared by using of sufficient high frequency in the what? Sufficient high frequency alternating current or sufficient high frequency ultrasonic vibration. In the sufficient high frequency ultrasonic vibration can be prepared by generator spread with the oil. Generator spread with the oil. It is a example of what? Ultrasonic dispersion. Next one, peptization. By using of peptizing agent. So peptizing agent nothing but electrolytes. By addition of electrolyte, for example, hydrochloric acid is electrolyte. In the electrolyte added to silver chloride salt. The silver chloride substance can be converted into silver salt or silver chloride salt by using of electrolyte. Hydrochloric acid is a electrolyte. The hydrochloric acid is act as a peptizing agents. Peptizing agent. These are four methods are dispersion method. The dispersion method is nothing but in the large size of the suspension container, colloidal suspension solution container, particle can be converted into colloidal solution. In the first one, the mechanical dispersion, example colloidal mill. Second one, periodic arc method or in the electrodispersion. Another one is ultrasonic dispersion. The last one, peptization. Peptization is nothing but by addition of electrolyte. Then the electrolyte break down the solid substance into colloidal solution. Then the electrolyte otherwise called a peptizing agent. In this process, hydrochloric acid act as a peptizing agents. Okay students, today topic over. Next topic we will meet the next video. Thank you.